Okay, welcome back, guys. So we're going to continue with the Unit 4 review. So in the last video, we looked at questions 1 to 8. Today, we're going to start with number 9. So with number 9, you have a table, and you have to continue the table and then write the equation. So it's the same thing we did in the previous questions on the previous video. We haven't really changed any skill yet. So we look at this one, our x values are going up by 1, so our y values in this case go 10, 20, 30, so they're increasing by 10 each time, so we can just continue it and say 40 and 50. So what would our equation be? Well, we would say y equals the coefficient to our x, the thing we multiply x by, is what we increase by. So y is increasing by 10 each time, so it'd be 10x, and then the value we add is going to be whatever that 0 value would be. What is y when x equals 0? So we're increasing by 10 each time. So when x is 1, y is 10. So if we go backwards to when x is 0, y would be 0. So we don't need to put the plus 0. If you had it, you wouldn't be marked wrong, but you could just put y equals 10x. Okay. So the next one, our x values again are increasing by 1, 5, 6, 7, 8, 9. Our y values are going 8, 9, 10, so they're increasing by 1 each time, and we can say 11 and 12. Okay, so for the equation, we would say y equals, and then our y's are increasing by 1 each time, so it would be 1x. And what would our 0 value be? So if our 5 value is 8, and we're going up by 1 each time, our 4 value would have been 7, our 3 value would have been 6, our 2 value would have been 5, our 1 value would have been 4, so our 0 value would have been 3. And so we can say plus 3. Okay. All right, the next one, so my x values are going 15, 16, 17, 18, 19. They're increasing by 1. And we're going 10, 11, 12, so we can say 13, 14. So we're going up by 1 each time in the y column as well. So again, we can say y equals, because we're increasing by 1 each time, we can say 1x plus, and we want to know what that 0 value was. So this time it would take quite a while to go, well, if the 15 value is 10, well, the 14 value is 9, and the 13 value is 8. You can do that if you want to, but we could also say it's 1 times x plus something should give us y. Well, if we did 1 times x for the first column, 1 times x would be 15. 15 plus what is going to give us 10? Well, 15 plus nothing gives us 10, but 15 take away 5 does give us 10. 1 times 16 would give us 16. Take away 5 would give us 11. 1 times 17 gives us 17. Take away 5 gives us 12. So that's back to that first method I showed you to find that value that's being added or subtracted. And in this case, it's minus 5. So sometimes finding the 0 value is a little bit easier, and sometimes it's not when you're dealing with higher x values. Okay, the next one. 1, 2, 3, 4, 5 in the x column, 3, 5, 7. So we're increasing by 2. We can say 9 and 11. So our equation will be y equals, because we're increasing by 2, it'll be 2x. And what is that 0 value? So when x is 1, y is 3, but we're increasing by 2 each time. So let's go backwards. When x is 0, we do 3 take away 2, y would be 1. So 2x plus 1 would be our equation. Okay. The next one, so these are more situational, but all we've done really is change the headings from x and y to different situations. So for example, the number of tickets and the cost. So 1 ticket is $6, 2 tickets is $12, 3 tickets are $18. You see we go 6, 12, 18. We're increasing by 6 each time. So 18 plus 6 would be 24. 24 plus 6 would be 32. So what would our equation be? We could say C for the cost of the tickets equals, so we're increasing by 6 each time, so we should say 6 times, let's say the N for the number of tickets, and then what is that zero value? So we're increasing by 6 each time. So if one ticket costs $6, we subtract 6 minus 6 and we get 0. 0 tickets cost $0, which totally makes sense. But we don't need that plus 0. So we can just say the cost of the tickets is 6 times N, or 6 times the number of tickets. Okay. The next one, we have the hours worked and salary. So 1 hour worked is $8.50. 2 hours worked is $17. 3 hours worked is $25.50. So this one you may have to use a calculator. If you're wondering how to use a calculator to figure out what you're going up by, I can look at $8.50 and $17 and say $17, take away $8.50, and I get, there's a difference of 8.5. So I've added 8.5, and then I can just check, do the next one. So I can say $25.50. Oh, 20, oh, jumpins. $25.50, take away $17, and you can see there's a difference of $8.50 again. Okay. So then, if you're not a big fan of decimals and you don't want to do that math in your head, to keep going, you can say $25.50 plus $8.50, or 8.5, would be 34. And then you can just say 34 plus 8.5 should be 42.5, or 42.50. Okay, so if you need to use a calculator, by all means, you can do so. Okay, so what would our equation be? So our salary, we'll say S equals, what are we going up by each time? We're going up by 8.5. If you put 8.50, you're not wrong. That's perfectly fine. So it's 8.5 times the hours worked. Let's use a small h for hours. Plus, what would that zero value be? So if we're going up by 8.50 each time, 1 hour worked, we earn 8.50. We'd have to subtract, and 8.50 minus 8.50 would just be 0. So it would be 8.5h plus 0. We don't need that plus 0. We can just leave it like it is. Okay. Distance in kilometers and time in minutes. So obviously we're traveling, and in 1 kilometer, when we drive 1 kilometer, 1.2 minutes have passed. 2 kilometers, 2.4 minutes have passed, and 3 kilometers, 3.6 minutes have passed. So if you look, what you're increasing by is 1.2. So 1.2 plus 1.2 is 2.4. 2.4 plus 1.2 is 3.6. And then 3.6 plus 1.2 would be 4.8. And 4.8 plus 1.2 would be 6.0, or just 6. So what would our equation be? We would say, let's say T for time equals 1.2, that's what we're going up by each time, times the distance, D for distance, plus what would that zero value be? Well, if 1 kilometer is takes 1.2 minutes, we can subtract. We're going up by 1.2 each time, so we subtract 1.2, take away 1.2 would be 0. We don't need it. So the time passed equals 1.2 times the distance. Okay, and this last one. So boxes sold, we're selling boxes of something. 10 boxes sold would be $5. 11 boxes sold would be $5.50. 12 boxes sold would be $6. It seems we're going up by 50 cents each time. So 13 boxes sold would be $6.50. 14 boxes sold would be $7. Okay, so our equation, we would say our profit equals So we're going up by 50 cents each time. So we can say 0.5 or 0.50, it doesn't matter, times the number of boxes sold plus what is our starting value. So this is one of those ones where we can count backwards, but we're counting backwards from 10, so we'd be here for a little while. So instead we can just say 10 times 50 cents would be $5. So I don't need to add anything to make that true. 11 times 0.50 would be 5.5. I don't need to add anything to make that true. So my zero value would actually be 0. So it would just be my profit equals 0.50 B. Okay. So now we have some word problems. So the pizza Brenda is buying costs $8.50 plus $2.50 for each topping. She wants to figure out the cost of the pizza with different amounts of toppings. So she started to make a table. So if she got the pizza with one topping, it would be $8.50 plus $2.50 for one topping, which would be $11. Two toppings, so she would pay $5 for the two toppings, $2.50 each, plus $8.50 for the pizza, or $13.50. Three toppings would be $7.50 for the toppings. $8.50 is the cost of the pizza, which is a total of $16. So which price doesn't change? The $8.50 for the pizza does not change. How much does the cost of the toppings change each time? So every time we add a topping, the cost of the toppings increases by $2.50. And those two values, this $8.50, this value that doesn't change is actually our zero value. So when we write our equation, we can say the cost of the pizza equals $2.50, that's what we're increasing by each time, times, let's say, the number of toppings, plus that constant value, which is $8.50. Okay. Let's see, Brent paid $4 to enter the carnival and $1.25 for each ride. So let's write an expression for the total cost of going to a carnival. So we could say cost is, so we would do $1.25 times the number of rides plus $4 to enter the carnival would be our equation. So if Brent started with $30, how many rides could he take? So we take our equation, but he has $30, so let's fill that in for the cost and we'll figure out the number of rides. So the first thing we need to do is subtract 4 from both sides, right? And we end up getting 26 equals 1.25 times the number of rides. And then we would divide both sides by 1.25. So we would do 26 divided by 1.25 and we get 20.8. So obviously he can't go on 0.8 of a ride. So how many rides could he take? Well, 21 he wouldn't have enough money for because he only has enough money for 20.8. So he doesn't have enough money for 21 rides, so he could take 20, put that in, he can take 20 rides, okay? So sometimes, even though 20.8 rounds up to 21, 21 doesn't make sense in this case because he only has enough money for 20.8 rides. So we can't say 21 because he doesn't have enough money for that, okay? Okay, so let's look at number 12. Mary makes $30 each day in tips and is paid $10 per hour. So let's write an expression. So she's making $30 no matter what, plus $10 for every hour she works. So we can say her earnings, let's say E for earnings equals $10 times the number of hours she works, plus the $30 she makes in tips. So that's what that equation might look like. So if she worked for 6 hours, how much does she make in total? So because the 6 is hours, we'll fill that in for H. So the first thing we do here is do 10 times 6, which is 60. And then we do 60 plus 3, which is 63. So how much did she make in total? She made $63. Don't forget the dollar sign there. Okay. And the last question we're going to look at today, there's 3 parts to it. It's number 13. So all we're going to do with these ones is we're going to graph them. So we're given a couple values. Oh, sorry, we're going to graph them and determine the equation. So we can determine the equation first because why not? So we're given -2 and -3, -1 and -1. 0 and 1, 1 and 3, and 2 and 5. So we'll say y equals, I'm increasing by, if you look, I'm increasing by 2 each time, so 2 times x. And the great thing about this one is my 0 value is already there for me. And when x is 0, y is 1. So 2x plus 1. That should have, you shouldn't have to figure that out. So to graph these, what we're going to do is we're going to open this graph in Google Draw, and we're going to plot each point. So -2 is my x value, and -3 is my y value, would be right about here. There's my x, and there's my y. -1 and -1 would be right about here. 0 and 1. 1 and 3, and 2 and 5. So let's see what that looks like to graph it. So remember to graph it, we're opening it up in Draw, and we're going to make some circles here. So my first ordered pair was -2 and -3, so it's going to be right there. Let's give that some color. Then we're going to do, what was my next one? -1, which would be here, and -1, which would be right there. So we'll do a nice little circle there. Not all the circles are the prettiest, and that's fine. It's no big deal. Okay, and then we'll do 0 and 1. So 0 and 1 would be right here. We'll color it red. And then we will do 1 and 3. 1 and 3, which would be right here. And the last one we will do is 2 and 5. So 2 and 5 would be right here. Okay. So then, because we're not given a situation, so I know we talked about discrete data and continuous data and when to draw a line and when not to. Because we're not given a specific situation, we're just given a set of values, then we can assume it's continuous and we can connect our dots. I'm going to fix this one a little bit. Oh, we don't need that. Okay, I'm going to fix this line because it's not right where I want it. Right about there. And right about there. Perfect. Okay, and there is my line right through my dots. Okay, so let's look at the next one. So my values, x is -2. Y is -7, x is -1, y is -5, 0 and -3, 1 and -1, and 2 and 1. So let's do our equation first. Get that part out of the way. So we can say y equals, so if you look, your values here, from -7 to -5, -5 to -3, -3 to -1, and -1 to +1, we're increasing by 2 each time. So we can say 2x. And then again, my 0 value is there for me. I don't have to calculate it. So when x is 0, y is -3. So 2x minus 3. So let's graph it. So we'll open this up and draw. We will grab our circle, and we will go -2 and all the way down to -7 and draw our circle. Okay, we'll do another one at -1 all the way down to -5. Okay. We will do another one at 0 and -3, which would be right about here. Our next one is at 1 and 1. Oh, sorry, 1 and -1. That didn't make sense for a second, which would be right here. And our last one is at 2 and +1, which would be right here. Okay. So those are our dots. Again, because we're just given the data and not the situation, we can assume it's continuous and we can connect our dots. Okay, and draw a line. Adjust it as need be so that it goes through all the points. And there is our graph. Okay. And the last one for this problem, we have x is -2, y is 3, -1 and 2, 0 and 1, 1 and 0, and 2, and -1. We've moved down a little bit here. Let's see if we can fix that up. So my equation for this one will be y equals, it looks like we're decreasing 3, 2, 1, 0, -1. We're decreasing by 1 each time. So that means we're going to say -1 times x because we're going down by 1 each time. And that 0 value is there for us. It's a +1, so we can say +1. So y equals -1x plus 1. So let's graph this one. So we'll get our circle here, and we'll -2. So when we were at -2, the y value was 3. So we'll draw our first circle. Then -1, and the y value was 2. Um, 0, and the y value was 1. Uh, 1, and the y value was 0. And finally 2, and the y value was -1. So then we can do our line. Which is pretty good right there. And there is our graph. Okay. So check out video number 3, which will have the solutions for numbers 14 to 16.